So this is a kind of a heady subject. You can get really into the nuts and bolts of how stuff works. I have some extra detailed slides in here that I'll just skip over, but I put them in here so you guys can reference the stuff later in case you're interested and have all the information you need to get going. So I'll be talking about Hackintosh, which is industry slang for running macOS on a PC. So just a quick thing about me. I worked in Japan for a while making music games, and then I came to Sweden in 2013, and now I work with Propellerhead Alihupa doing mobile development for iOS and iPad. Quick disclaimer to save my butt when this gets popular in the future, or doesn't, just kidding. Actually using macOS on non-Apple hardware is a violation of the EULA. I was curious as to how Travis is doing this then, but actually what Travis does is they have a bunch of Mac Minis. They run virtual machines of macOS on the physical Mac, which makes it okay. There's a loophole there. But when you put macOS on a PC, that's not cool. So it is a violation of the EULA. Apple could come after you if they were really bored and their lawyers ran out of things to do. But that has never happened thus far and probably won't happen unless you try selling these yourself. That said, macOS could break all this stuff at any point in time, so I wouldn't recommend doing it on your only build machine or the only computer you have in your company. So, despite those challenges, why would you want to have a Hackintosh? Well, there's a great couple of reasons. One is that it can be faster, especially right now that the Mac Pro hasn't been updated in a couple of years. It can also be a lot cheaper, as you'll see in a minute. And it's kind of fun to build things that not many other people do. I say not many other people, but actually lots of other people do this. There's a number of sites on the web that you can find that gives you all the information you need with users and walkthroughs and even formulas about which hardware you want to put together that's guaranteed to work. I use a site called TonyMac, x86.com, which I actually think I got from an article from you last summer.
Oh, really?
Yeah. Yeah, he turned me on to it, and I was like, oh, I'm going to try it out. So it actually worked out really well. So first thing you need to do is need to build the rig. This is a list of everything I bought for my Hackintosh. It had, at the time, the latest Intel Skylake processor at 4 gigahertz. I had 64 megabytes of RAM, and a SSD that's as faster also than anything you can get from Apple these days. And you see down here the total is only 15,000 crowns, which I think is cheaper than most MacBook 13 inches that you can put together right now. So this is the list of stuff. If you are curious on this later, you can go through the details, but it's basically just CPU, motherboard, cooling, RAM, and a case. It's also a lot of fun, like I said. So I felt a little bit like Christmas when we ordered all the parts, and they all arrived at the same time at the company office, and we took all the boxes out and put them on the kitchen table in the office, and we're like, yay, now we get to put together all this stuff, all these shiny packages, and fancy words like ultra durable and GeForce and extreme and things like that. So we thought this would be a great team building event. So we had a little build party after work where we went to the kitchen, we put a cheesy movie up on the screen, we got some beers and Cheetos, which actually was not a great idea considering we're handling silicon and other sensitive parts. Fortunately, no beer or Cheetos ended up directly on the hardware, but there was a lot of clean rooming going on between that. So we put the case and take out the pieces and put them together, and people tell other people, oh, you think that's the way you insert a slot? That's not how you insert a slot, and there are all kinds of bullshit going back and forth. But it was a lot of fun. And we spent about 2 hours putting it all together, and then it didn't run. So what did we learn? We learned that it's important which order you put the pieces into the case, especially because even the biggest cases have a lot of things you need to navigate to get these huge graphics cards and stuff in there. It didn't turn on at all. So what I ended up doing was just unrolling the stack then, taking things out until it did start. It turned out that 12.5% of all the RAM we got from Dustin was bad, and that's what prevented the machine from turning on. So just removing sticks of RAM until it got past that part. And then we realized, okay, this is just a bad memory chip. So now you've got your machine put together. You've got the hardware there. It's turning on. What do? Now comes the fun part. So there's a number of pieces of software you'll need that you may not be familiar with. The first is the UEFI, which is a modern replacement for BIOS that allows you to have little programs that run before the computer actually boots up to the operating system. Next, the software that I use is called UniBeast, and it's free software that lets you make a bootable USB stick of macOS. And then Multibeast, which is another piece of free software which allows you to build a special configuration for your PC Mac. Obviously, Apple has assumptions about which hardware is going to be inside the machine, so you have to tweak it a bit to say this kind of graphics card is all right, or it's okay if you don't have this kind of Bluetooth and things like that. And Multibeast helps you build a plist, which basically then patches your version of Mac OS. So when you boot it up, it will look just like a normal Mac to the operating system. Finally, the way that you get into that is through the bootloader. The bootloader that we use is called Clover, and Clover can boot other operating systems as well. It basically gives you a way to patch an operating system with special kernel extensions and other parts of the operating system that need to be replaced for custom hardware. And you can configure Clover via a separate free application that you can use just to make it a wizard-based thing, so you don't have to go diving directly into plist if you don't want to. And finally, yes, the kext. The kext are the things that it's like a driver, basically, in Mac OS, the equivalent of a Windows driver, and it's the thing that lets the hardware talk to the operating system and work out okay, and talks about what regions of memory are accessible by what. So this is what UniBeast looks like. You can get this from Tony Mac. Same with Multibeast. It's just a wizard that you run on your safe real Mac to get the configuration files that you need. And then Clover. So when the build machine boots up, or the Hackintosh boots up, from here you can pick whether you want to do it from one installation or another partition and things like that, or configure emergency mode and all that kind of jazz before you slip into your real version of Mac OS. So the flow is really simple, actually. First, you just make a USB stick of Mac OS with UniBeast. Then you have that stick you can boot from. You boot onto that, and then you install Mac OS onto the SSD inside of your PC. And then you run Multibeast on your safe Mac to then build the Clover Loop bootloader and patches that you need to swap in on top of the Hackintosh. And then finally, you get video drivers, which are not going to be covered by this. NVIDIA is the card that we use. I mean, if you have video cards, probably either ATI or NVIDIA. NVIDIA releases drivers which run on PC Macs, believe it or not. I don't know why. I guess because they want you to buy their cards. They don't explicitly say that's what it's for, but you can get drivers just as if you could plug an NVIDIA card into the other Mac. So that's the basic flow of how you set up your Macintosh or Hackintosh. So now you have your machine. It's a really fast, awesome PC. It boots up into El Capitan or Sierra, whatever you want. And now we're talking about continuous integration, which is the key reason why we built this. How many people have not heard of Jenkins before? Okay, so Jenkins is a piece of Java software that lets you basically automate tasks for, in this case, building your XCode applications and running tests for you and distributing your stuff. So if you want to get more information about Jenkins, there's lots and lots of information out there on the web and also on Stack Overflow. But basically, Jenkins is the key program that we're running on this Hackintosh. So if you want to get Jenkins to run, the idea here is basically that you just start with the installer, then you add everything you would need if you were doing a regular dev machine, XCode, your source control, plugins for Jenkins, and then you copy jobs if you're coming from another, perhaps slower Mac Mini, for example, which is what we did. And then you just tweak the environment to make sure the permissions and everything work properly. Finally, because this is going to be running headless, you're probably going to be doing it through XCode build on the command line. You need to go through the whole XCode, like open it up once and then get the EULA dialog and then build something and then sign. Because if you sign, it's going to try to access the keychain for the first time. And to do that, you're going to get this dialog box that pops up that says XCode wants to access the keychain. You can't have that in a headless situation because it'll just hang and the job wouldn't finish. So you have to manually walk your build machine through the process of building an executable and then signing it once until you have all the permissions and keys sorted out. But after that, you can basically just unplug the monitor and not look at it for months at a time, and it will be fine. This is the details. I'm not going to go through this, but if you wanted to know, this is what I had to do to get Jenkins running on my Hackintosh. Like everything which is weird and archaic, it gets easier once you do it multiple times. The first time you'll be kind of scratching your head. But this is a de facto recipe that I had to get it running just a couple months ago. So now we have Jenkins running. It's going to do build jobs for us. It's going to build our distribution and make binaries, send out our builds to our testers, and make sure that we're running happy with a good, safe code environment at home. How much faster is it? Was all this trouble worth it? So we have a Mac Mini doing a single job, which is just running through a C++, Objective-C, and a little bit of Swift built shared application, and I archive it, and then I send it up to a test distribution service. On the Mac Mini, it took about 3 minutes and 15 seconds. On the Hackintosh, it was about 33% faster. So that's a nice increase in performance, and this is just doing one single thing. The great thing about using this really monster machine that you've built is you have more RAM, more processor, more cores, and you can do more stuff at once. So if you want, you could have multiple ones of these all running at the same time. XCode, unfortunately, does not support parallel compilation on the same target, so you're not going to see performance on a single job, probably. But if you wanted to have multiple jobs, maybe you have 3 applications you're making, and you modify a core package, and you check that in, and then you have all the jobs, all the applications running to check and make sure it's all hunky-dory with that, or you have multiple tests. This will work, but you have to make sure that the derived data path then is unique for each one of these jobs. Otherwise, the compilation will probably be like XCode will try to write to one Swift compiled file at the same time another job does, and then you'll get these kind of scary, could not access disk type errors and things like that. You might start worrying, oh my God, my machine's dying, what have I done? But actually it's more of a permissions-based thing than your hardware crapping out on you. So, you got a faster machine, you have Xcode, it's doing jobs, everything's great, and then you need to update something. Maybe it's macOS, maybe it's a driver, maybe it's your version of Xcode. This is the part where the karma comes back and gets you. It's not quite as smooth updating stuff on a Hackintosh as it is on a regular Mac. So let's say you want to go from El Capitan to Sierra, for example. Every time there's a new revision of macOS, even if it's a point release, the NVIDIA driver changes because the NVIDIA driver has this thing baked into it that says, I'm only good for macOS build 1, 2, 3, 4, 5 or something like that. So you'll need to update your NVIDIA driver if you want to go to like a 0.5 to a 0.6 of El Capitan. Another thing is if you move through major updates, like from a 0.2 to a 0.3, like Sierra 0.2 to Sierra 0.3, it could be that permissions have broken. This will almost certainly happen if you go between macOS, El Capitan, and Sierra. That happened to me just recently. So then everything was fine. All of a sudden you're trying to run your stuff, and then Jenkins can't even start up, and you go hunting. Why was that? Jenkins was accessing some shared files and configurations in a shared folder of home, and Sierra made the security more enhanced, so Jenkins no longer has the authority to do that. So you have to go in there and do some change own wheel stuff and get it all back to where it was before. VNC may not work, and the host name of the computer may even reset, which is something that I had just recently. Couldn't find it anymore. Like, what's going on? And the Hackintosh started calling itself iMac for some reason. But fortunately, we could fix that easily. So the way this works is you get your macOS installer, for example, the Sierra one. You make sure your Clover, your bootloader, is updated, and then you copy the CACs from that new version of macOS to your EFI mount, so that when the computer reboots, it will know that that new version of operating system is valid. Otherwise, you wouldn't see the mount for the installer. You run the installer, you reboot it, and then you go through the process of updating the software and App Store, and you update your NVIDIA drivers, and then you fix all the permissions problems and stuff that I just talked about. This is the detailed 18 steps to update from El Capitan to Sierra. It was not quite that bad. I think that we got it done in like 4 hours or something like that, Caesar. It wasn't so bad. It was just like a Friday afternoon. Yeah, XCode. Unfortunately, sometimes XCode requires a new version of macOS, hence the updating macOS. Based on the way Apple's been updating things in the minimum required version recently, I'd say about every 18 months is when you have to go through this process of updating your version of macOS. XCode can also break Jenkins because there's a Jenkins plugin just for XCode, and that gets out of sync with how XCode wants to do stuff, like packaging and signing, and this is now deprecated. You can't do it this way. It used to work, but we didn't admit that it did. Now it's considered a bug and things like that. If you pay attention to the detailed Jenkins log about warnings and tools, you'll find out what the problem is fairly quickly and be able then to home in on what you need to repair. NVIDIA wants to give you the latest drivers. Don't let them, because they're probably not going to be compatible with your version of Hackintosh OS right away. Talk to the forum. Go check it out. There's lots of guys in here that are like frothing at the mouth to get the latest version of macOS and NVIDIA all the time. So if you just wait a couple days, someone will have posted the correct drivers, and it's rather painless to update. So, a couple tips. Keep in mind when you're setting up your machine, what configuration. Our Hackintosh ghosts itself as an iMac 14.2. This is just because this is the most compatible iMac for receiving all different kinds of weird stuff. Newer versions of iMac, like the 5K one, have problems with power management with monitors and things like that. And the guys on Tony Mac will tell you which one they recommend. I talked about drive data if you want more than one job running at once. And finally, just make sure you do lots and lots of backups. It's very easy to make backups off-site these days. We have multiple stuff. We have a full disk image going to an in-house server, which is backed up to Glacier on Amazon. And we also have a separate, smaller backup just of the configuration for Jenkins. So it's very easy to get up and running with that again. And of course, if you're not already, update your DSIMs and your XC archive files for the builds that you send to Apple and stuff like that. Here's some links. Check them out. That's it. So you can ask me any and every question about this, and I'm happy to give information.
Yes, we have a microphone, so we can record questions as well. So, any questions?
Have you guys tried running multiple SSDs in RAID 0? For example, Samsung allows you to have this feature, and usually the disk is the bottleneck for performance.
Yep.
And we tried with RAID 0, but it doesn't look at it as one disk, and sometimes when files got spread over multiple disks, you have problems with the read-write permissions for them. Have you managed to make that work?
I have not tried a RAID 0 on Hackintosh yet, no.
Okay.
But you're right, that probably is where the bottleneck is right now.
It's incredibly good.
Yeah.
Like when you get it right, but it's very hard.
Just to add on to what he was saying, I did some compilation benchmarks using a super secret project that, well, it's a Spotify client, on my Mac Pro, and that took about 10 minutes for a MacBook Pro from a couple of years ago to compile. The Mac Pro did it in 6 minutes, and the Mac Pro with a RAM disk, with everything in RAM, including the source and the derived data, took like maybe 30 seconds faster than just with the Mac Pro's SSD. So there is a bottleneck there. But if you have a fast modern SSD these days, a RAM disk will get you a bit, but not a huge amount.
Yeah. That's true. If you have 64 gigs of RAM, that's a fantastic place to use it in. Yeah.
Any more questions?
A little bit unrelated, but how about, do you know how much internet you need when you sign apps? Can you just, I think it needs one call to Apple to sign, right?
I don't know. I've never tried actually signing an app offline. I feel like I have, but I don't know.
Okay.
I'm sorry.
And the other one was, how about upgrading Xcode? If you let's say you stay with some OS because it's troublesome to upgrade. Signing, you probably need the latest Xcode anyway, or do you get around with it quite?
You can get around that. Apple has their own limits on like, okay, all apps that submitted after this date have to be done with Xcode, blah. But it's actually kind of old. You have a lot of leeway there. usually what you'll get squeezed out of is something with Swift or something like that. Like you want to run Swift 3 or some other library you're using uses Swift 3, and then you can't support that. And that's where you get pushed into a newer version.
I'm wondering about the NVIDIA graphics.
Uh-huh.
Is it possible to use Intel graphics and maybe get a problem less?
Yes, it totally is. The reason that we used NVIDIA was, I think most people use make Hackintoshes do it for games also, which is nice. But the only downside to not using the Intel driver, in my experience, was that the VNC got really slow. So I'm trying to remote log into my machine, and I'm getting like serious cursor lag and things like that because the default Intel driver only reports as having, I think, 8 megabytes of video RAM, which is ridiculous, and that's almost impossible to use for like a HD screen. Other than that, yeah, you don't need an NVIDIA card.
What's the big reason for doing this instead of using like Travis?
That's a good question. And maybe
like the hassle, extra hassle instead of.
Yeah. We've had that discussion a lot ourselves in the past couple weeks because we use Travis too for another project. With Travis, you gain in not maintaining the environment, but you lose in speed. Travis is slower. With us doing the same thing now, even though we pay for Travis, we still have really slow compilation times. And secondly, when Travis breaks, it's kind of harder to troubleshoot. When it does go wrong with our build script, we've spent more time digging into what the heck is going on. Then with Jenkins, it's quite clear and it's easy to fix sooner. So I guess how lucky you feel in terms of your support overhead on the jobs and how much build performance is a thing for you.
Right. No more questions? Okay, well then, thank you very much, David.
Thanks a lot.